Hey everyone, and welcome to The Explainer. Today we are getting our hands dirty. We're going to dive into a protocol that is fundamentally rewiring how AI connects to the world, the Model Context Protocol, or MCP. We're moving past the high-level talk to give you, the builder, a really concrete look at what this thing is, why it solves that integration nightmare we all know, and most importantly, how you can actually start using it. So if you're a developer working in the AI space, this question probably hits a little too close to home, right? You find a great new LLM or a powerful new API, and you think these two should talk. But getting them connected means writing yet another piece of custom one-off code. It's this constant, frustrating cycle that just piles up the technical debt. And this isn't just some small annoyance. It actually has a name, the N by M problem. Just picture it. You've got N different AI models, Claude, Gemini, GPT, you name it, and M different tools, your GitHub, your Slack, your company's internal database. Trying to connect every single one to every single other one, well, it's an explosion of custom connections that you have to build, you have to test, and you have to maintain. So what does this integration mess actually look like day to day? And maybe more to the point, what's the real cost of it? Okay, on the left, you see the chaos. It's a spaghetti monster of connections. Every AI model needs its own bespoke connector for every single tool. This isn't just doing the same work over and over, it is a maintenance nightmare. An API updates over here, and you have to go fix a dozen different connections. But then, look at the right. That is the promise of MCP. It's a clean, simple, hub-and-spoke model. Instead of that tangled web, you build one connector for your tool, and suddenly every model can use it. That is the breakthrough. So how do we get from that tangled mess on the left to that beautiful, elegant solution on the right? The answer is an open standard that is quickly becoming the universal connector for the world of AI. And here it is, the Model Context Protocol, or MCP. It's an open source standard, and honestly, the best way to think about it is this. It's the USB-C port for AI. Seriously. Just like USB-C finally gave us one standard port for all our gadgets, MCP gives us one standard protocol to connect any AI to any tool. It all happens through a simple JSON RPC-based communication layer. And the architecture is just beautifully simple and modular. So first, you have the host application. That's the AI app the user is actually interacting with, like your IDE or a chatbot. Inside that host, there's an MCP client, which basically acts as a universal translator. And finally, you have the MCP server. That's the lightweight wrapper that you build around your tool or data, exposing what it can do in a standard way. The client and server talk to each other, and the best part? The host and the tool, they don't even need to know the other exists. This quote, this gets right to the heart of it. This is the core promise of MCP. Ship one integration, use it everywhere. You create one MCP server for your tool. You build in the auth, the error handling, the versioning, and boom, it's instantly compatible with any app that speaks MCP. This is how you finally escape that N by M trap. Okay, this all sounds great in theory, but how do you actually start building with MCP? Let's walk through the roadmap for builders. It's probably more straightforward than you think.
It really just boils down to these three key stages. First, you define what your tool can actually do, its capabilities. Second, you implement the server, probably using an official SDK, and you handle things like how it's going to communicate and authenticate. And third, you integrate that server with a host application, making sure you have good testing and observability in place. We'll touch on all of these. Now, to really get this, let's look at the building blocks with a simple help desk server example. You define its capabilities as one of three things. A tool is a function the AI can call, like create ticket, and this needs a really strict schema for its inputs and outputs. A resource is just a piece of data the AI can read, like a company FAQ document. And a prompt is a reusable text template, like a standard format for a ticket summary. So when you're implementing your server, you have to pick a transport layer. For local development, when the client and server are on the same machine, STDIO is perfect. It's fast, it's simple, but for remote connections, like a production server running in the cloud, you're going to use HTTP with server-sent events, or SSE. This method is built for multiple users, and of course, it requires real authentication, like API keys or OAuth, passed right in the request headers. And now we get to the really cool part, the payoff.
Let's see how building just one server can empower a whole suite of different AI assistants all across your organization. All right, imagine your team builds one single e-commerce ops server. It has tools like get_order status, it offers a resource, the company's official shipping policies, and it's got a prompt template for apologizing about delays. And you can build in really solid governance here, like versioning your tools and using a secure vault for your backend API keys. Instantly, that one server can be plugged right into an AI-powered code editor, like VS Code or Cursor. This lets your developers query order statuses without ever leaving their IDE. No more context switching. And every single call can be logged with a trace ID, giving you complete observability into how these tools are actually being used. But it doesn't stop there. That exact same server can also power a dedicated AI app like Claude Desktop. This could give your support team instant, secure access to order data. And you get proper error handling. If an order ID doesn't exist, the server sends back a structured not found error, not just some generic failure. That allows the AI to respond much more intelligently. And finally, that same integration can be connected to an internal Slack bot. Now your entire operations team can interact with your backend systems just using natural language. So that's one server, built once, with robust testing. We're talking unit tests, contract tests, the works, securely empowering 3 completely different teams and workflows. And here's the best part. You are not starting from zero. The MCP ecosystem is absolutely exploding. There are over 1,000 official and community-built servers available right now for everything from GitHub and Stripe to Docker and Postgres. You can leverage all of this today, which saves you a massive amount of development time. Okay, so let's pull all these threads together for a second and just think about what this really means for the future of building with AI. So to recap, MCP lets you standardize all your integrations, creating that universal language for AI. This, in turn, lets you drastically reduce development effort, not just in the initial build, but in testing, monitoring, and security down the line. You get to build truly interoperable toolsets that are portable and versioned and just work everywhere. And finally, you get to join a massive and growing ecosystem, tapping into a vibrant open-source community that's building this future right alongside you. And this really is the question that MCP leaves us with. It's breaking down the walls that have separated our models and our tools for so long, creating this truly composable AI landscape. The possibilities, they're no longer limited by how much custom code you can write. They're only limited by your imagination.